Well, we've got this parametric function here, and because the x value has cosine, then I think in order for it to graph the whole thing, I should go from 0 to 2 pi for the domain. And I'm going to switch over to the TI calculator. And there it is, because I was practicing before you got here. Okay, so go to y equals, make sure that it's in parametric form. There's my cosine and my tangent. For the window, I'm having the t values go from 0 to 2 pi. And then this, I could say x is -3 to 3, and y is a little bit bigger, -10 to 10. And then it unexpectedly quit. Okay, so on the graphing calculator, it actually made a mistake. So the graph over here, the right side is good, the left side is good, but then it has this line in the middle, which is not supposed to be there. So the reason that I believe that line is not supposed to be there is because the y value is tangent. So that means that as the t is getting close to pi over 2, this is going up to infinity and never reaching the y-axis. So how could it be that it jumps from here onto that line and the calculator won't even put the little target symbol on there? So that line is not supposed to be there. So you could just ignore that line and then graph it. Or you could go over to something like Desmos, and then you do have to type it as an ordered pair. So the x component was cosine and the y component was tangent, and I had to go from 0 to 2 pi. And then they don't have that random line in the middle. Okay, so one thing was to graph it. So the graph was basically like a bell-shaped curve over here, except on its side, and then another mirror image of it over here. Oh, that is beautiful. That gets a happy face right there. Okay, there's the graph. Then for some math, eliminate the parameters. So eliminate the parameter t. So I need to somehow get rid of the trig functions. So there's tangent and cosine, and I'm thinking if I divide them, I would still have a sine because tangent's sine over cosine. So I'm going to use the idea that 1 plus tangent squared is equal to secant squared. So if I just take the second equation and square both sides, it's going to say y squared equals tangent squared. And then I could add 1 to both sides. And after I do that, the right side becomes secant squared. So now I have 1 plus y squared is equal to secant squared. And then the good news with that is that secant is 1 over cosine. So that means that the right side is 1 over cosine squared. And in the given problem, x is equal to cosine. So that means that this becomes 1 plus y squared equals 1 over x squared. And if you're going to solve for y, you would, of course, need to subtract 1 from both sides. And then if you take the square root, make sure that you put plus and minus, because otherwise it'll only give you half of the graph. So there we have it solved for y, and the parameter is eliminated.